All right, today we're looking at, it's lesson 6.6. You're going to want to make sure to take some notes and label them. Geometric sequences. I previewed it a little bit yesterday. We know a sequence is just an ordered list of terms, and arithmetic means that we're adding or subtracting. When we have a geometric, that just means we're multiplying between terms. Now remember, if we multiply a whole number, like if we multiply something by 3, then that pattern is going to grow. It's going to get larger. But if we multiply something by 1/3, then it's a pattern that's going to get smaller. So just because we're multiplying, it doesn't mean that all of these are going to grow. They could be getting smaller or larger. It just depends on if we're multiplying by a fraction or multiplying by a whole number. But geometric means that we are multiplying. When we are multiplying, or whatever number we are multiplying by, instead of it being called a common difference like it was with arithmetic, it's now called a common ratio. We still have things that are called terms. That doesn't change. But when we're dealing with a geometric sequence, we now have what's called, again, a common ratio is the number that we're multiplying between them. We can always find, and this is more helpful with a geometric, we can always find our common ratio by doing the second term divided by the first term, and that will give us our common ratio. When we're multiplying, especially when it's by a fraction or something, it can be kind of difficult to see what the common ratio is. So I would make sure to have this down, the second term divided by the first term. Now, you're going to have questions. Determine whether each sequence is arithmetic, geometric, or neither, and this neither can make it a little bit tricky. I first want to look to see, well, the way that I approach these is I always first look to see, okay, is it arithmetic? So if I do 60 minus 120, that gives me 60. So if I do 120 minus 60, that gives me 60. Minus 60 again, that should give me 0. So it can't be arithmetic because these two have a difference of 60. If I subtract it again, I don't get 30, I get 0. So it's not arithmetic. Geometric, I'm going to do my second term divided by my first term. Well, 60 divided by 120, that's 1/2. If I do 120 times 1/2, I get 60. 60 times 1/2, I get 30. And 30 times 1/2, I get 15. So this tells me, okay, this is geometric. Usually these will ask you to explain. This right here would be enough of an explanation for me that you show me, look, we're multiplying all by 1/2. Now you need to be super careful because something that I could do is instead of having a 15 here, I could have 16. So that would mean that the 1/2 works for the first one and the second one, but 30 times 1/2 is 15. It's not 16, so it would not work for this one. This is where we would get an answer of neither if we're not adding by the same amount or subtracting or multiplying by the same amount. So you do need to make sure, just like I did up here, you need to make sure you check your common difference or your common ratio through all the numbers because it might work for one or two of them. We got to make sure it works for all of them. So that's one thing you're going to be asked to do. Determine what type of pattern, what type of sequence we are looking at, if any. Also, you're going to be asked to write the next 3 terms of the sequence. Well, again, this tells you here that it's geometric, so we know that we're multiplying. We don't have to determine what it is. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. If I want to find the next 3 terms, I'd have to do 24 times 2, which gives me 48, times 2, which is 96, times 2, which is 192. So my answers would be 48, 96, and 192. Those are the next 3 terms. This one, it's very difficult to see what the pattern is. Again, I would do the second term divided by the first term. Negative 16 divided by 64. Oops, that should give me 1/4. There we go. This gives me negative 1/4. So if this term is negative 1, to find the next one, I do negative 1 times negative 1/4. This gives me positive 1/4. That times negative 0.25 or 1/4 as a fraction would be 1/16 times, oh, it should be negative. There we go. times negative 0.25. As a fraction, it would be negative 1. Oops, not negative. That's back to positive. 1 over 64. So again, this is where it can be difficult to see the pattern. It's changing from positive to negative, back and forth. Second term divided by the first term can be really helpful. If we were, I'm not going to go through this whole thing, if we were to graph these, it's going to look just like your exponential growth curve. That's why we're doing these right now, because a geometric sequence is the same thing, or very similar, to an exponential growth curve. And you will see that a little bit here with our equation. Just like with an arithmetic, a sub n just means that's the term that we're looking for. A sub 1 stands for my first term. R is my common ratio. N is just the term position that I'm looking for. So if I say, hey, I want you to find the 150th term, you're going to write this equation and plug 150 in for n. One thing to pay attention to, this would be considered an explicit equation. Remember yesterday we looked at the difference between explicit and recursive. This would be the explicit form. This would be the equation form. If I were given this pattern, write an equation for the nth term. Well, my formula is a sub n equals a sub 1 times r to the n minus 1. A sub n equals my first term is 2. It tells me this is geometric, so I don't have to try to figure out if it's geometric, arithmetic, or whatever. It tells me what it is. And it looks like I'm multiplying by 6 every time. So my r value would be 6 to the n minus 1. It's asking me to find the 10th term. So I'm going to find, this is part 1. Now part 2 is find the 10th term. I'm going to put 10 in for n. Two parentheses 6 to the 9th power gives me 20,155,392. 20,155,392. Oh, I should go over. If I were to ask you, let's say we had this same question, and instead of writing an equation for the nth term, I said write a recursive rule. Well, your recursive rule, remember, you say, okay, here's what my first term is, and here's how I find the next one. Well, my first term is 2. For my next one, I'm multiplying by 6. So when we write a recursive rule for a geometric, we usually write the number first and then do times a sub n minus 1. Remember, with the recursive rule for an arithmetic, we typically put a sub n minus 1 first and then put plus or minus the number. Here we put the number first, just to make it a little simpler. All right, now those are all of your examples. Next, you're going to head to knock out a big ideas.